to identify, okay, when presented with a acid or a base, you need to identify whether it is a hard or a soft acid base pairing. Okay, right. So this is the qualities of your hard acid and hard bases, soft acids and soft bases naman dito. Okay, so your hard acids are small in size but high in charge, meaning they are highly polarizing. Hard acids are low in electronegativity. The electronegativity is very very low here, meaning ang imo hard base should have large electronegativity because they would form an ionic compound. Okay, ionic compound again should have a great difference in ionic and electronegativity, making your ionic bond. Okay, this is why ang hard acid low in ionic electronegativity, while your hard base should have a high electronegativity. Okay, since this one is polarizing, this should be um polarizable na. Okay, because this is a hard base, meaning small. Since okay, meaning it would be alright, so it would be weakly polarizable, right? In terms of size naman, all hard bases would have small size but high charge. Usually, these are your halides na oxyions due to the ionic bonding. Alright, so in terms of the bond order, your R2O would have the greatest ionic bond right here because oxygen has the is the most electronegative. Okay, so that is how you actually compare na bond in the order, right? So bonds with oxygen donor would be the greatest because of the um, large change in electronegativity forming your ionic compound. Right, so your for soft naman, soft acids, these are high in size now, big in size, but small in charge, hence making them weakly polarizing. Okay, these are your middle class elements in your periodic table with an intermediate electronegativity. In terms of bond order, okay, you start with your oxygen, sulfur, nitrogen, with phosphorus being the greatest now because phosphorus is a big atom. Okay, remember that soft should have um, um, large size now, so makes sense that phosphorus should have the most covalent character in the strand because this is a lot bigger na than your oxygen. This is the most electronegative. This is the biggest atom. Okay? In terms of a soft bases naman, it should have high size. So, okay? So, big size, small charge, making them a lot polarizable. Okay? This is your intermediate electronegative atom, such as your carbon. Okay? So, anything with carbon on it, such as your carbon monoxide, okay, cyanide, this one is CN, no? Cyanate, no? Due to the are all due to the covalent bonding, okay, experienced by this carbon because carbon is a soft, okay, okay, because carbon is has an intermediate electronegativity in it, and it would prepare an equivalent bonding. Okay, so remember this trend. Okay, this is fixed no for hard acid and hard bases. Okay, so if tinatamad kayo mag-memorize ng hard and soft acid and bases, you just need to know this general trend right here. Okay, so how do you actually memorize this one? Okay, so if low ang electronegativity for this, matic, no? Dapat high ang electronegativity for your hard base. Why? Because you are forming an ionic compound. Okay, so for this one, intermediate lang electronegativity because you are only forming covalent bonds no? Or compounds. Right? For your soft, it should have a high charge or big size, no? For soft acids and soft bases, but low charge. Okay? If it's a soft acid, it should be weakly polarizing. Okay, because it has a big size. Okay, compared mo kay imo, hard acid. It has a small size, meaning it is strongly polarizing. Okay, so in terms naman sa bases mo, it should either be polarizable. Okay, if it is a soft acid, it would be weakly polarizing. If it's a soft base, it would be highly polarizable. Okay? Because of the large size. Okay? Dito naman, low size. Hence, weakly polarizable. Okay? So remember this general trend. You don't need to memorize everything in the next slide if you know this pattern. All right, so this is your example of your hard acids, hard bases, borderline acid and bases, and your soft acid and bases. Okay, so If you have time, you can actually memorize this one. Okay, I'm not limiting you to that trend. So your hard assets are small in size, okay, but large in high charge. No, so your alkaline metals. No, those are examples of your hard asset. Okay, small, di ba, ang lithium, sodium, hydrogen. No, and your charge is it gets greater na from here. Okay? Umabot siya ng 3. Okay? So, this is your hard acid. Hard bases naman are small, no? Okay? Small and high charge. Okay? These are your fluorine, okay? Hydroxide, water, ammonia, okay? Carbonate, nitrate, no? Your oxides, no? Your sulfate, phosphate, and chlorate, no? You would have that for your hard acid. Okay, why? Because this um ones right here has high charge, making them a hard base. Okay, they are anions. Okay, so they are small but high charge, forming your ionic compounds. Okay, this one is small and small now, so hard bases because these are anions right here. Right, so for your soft acids naman, you have your copper, gold, silver, no, mercury. Remember, this one is your mercury. The most stable form of your mercury is Hg2 plus 2, right? So the atomic, you have your right here. Okay, so try to memorize this one. All right, so you have your boron hydride right here. Compare mo to your boron um trifluoride. No, since this your fluorine here is electronegative, the most electronegative element in the periodic table, it would um form a smaller acid. No, because of the electronegativity induced by your fluorine compared mo kay boron hydride. No, right? So this one is soft because this one is a lot bigger than your boron trifluoride. Okay, so that is how you compare those things. Okay, so for your soft bases naman, you have your hydride, no, your alkyl, no, your cyanide, carbon monoxide, and iodine. These are big atoms with small charges on it, making them a soft base. Okay, this one is your compound right here. When bonded with to S, okay, this one would be a soft base. But when bonded to N, this one would be a borderline base, meaning in between hard and soft. Okay, this one would be soft because sulfur is big now, so it would form your covalent compounds. Again, soft bases are low in charge but high in size, okay, or big in size. Okay, remember that trend. All right, so carbons are relatively soft, so they are in the soft bases. Right. So this one are borderline, meaning they are in between. Okay. So how do we know that? How do we classify if you have a borderline acids and bases? So when you encounter borderline acids and bases, usually you need to compare it to other acid, no, in the same chemical equation to determine whether it is acting as a soft or hard, no. So this one should have your you could actually use a reference for your borderline acid and bases. Okay, so you don't need to memorize everything. You just need to know the trend. No? Hard acid and bases are small in size, big in charge. Small soft acid and bases are big in size, small in charge. Okay, borderline are in between. Okay, you could actually compare it when you use it in your chemical reaction, right? So I hope I'm being clear. Okay, so this one is taken from Atkins and et al. 2010. Okay, right. So if you know how to determine your soft acid, hard base, soft base, you should actually know their application. Okay. So the first application is predicting the stability of a compound. Okay. For example, the complex formed with a soft preference are more stable with a hard soft compared more with your hard soft interaction. Okay, so first off, you need to determine whether silver plus is soft and iodine is a soft base. Okay, so at the back of your mind, you should actually open your periodic table in this case and try to guess or try to educatedly, hypothetically guess whether it is a soft base, hard acid, soft base, hard acid. So silver is big, go small charge, low charge, meaning this one is a soft acid, right? Iodine is big again, so soft. Negative, negative 1, small charge, meaning this one is a soft base. Okay? So, ang formation na mangyayari is a soft-soft interaction, making this um, product here relatively stable. Okay? So, yun yan. Okay? Um, Silver is a soft acid because it is big and a small charge. Iodine naman is a big molecule na. It would be a soft base forming your SS or stable compound. Okay? So this is how you determine whether a certain chemical reaction or product is stable. Okay? You apply the H sub. Right, again. So, again, you use this. Silver is a soft acid. But fluorine now is a hard base, okay, forming your SH soft hard interaction. This one is unstable. So, ang reaction would be favored. Okay, so ganun lang yan, right? So this one is stable. The backward formation is, if this one is reversible, okay, ang backward formation or reaction would be favored, right? Okay, so predicting the outcomes of some reaction. So, you could actually use your H sub to determine the outcome of your reaction, whether ang direction is forward or backward. Okay, so first off, you need to know, you need to compare the cations. Okay, lithium and cesium. Okay, open your periodic table and look if lithium is smaller than your cesium. Okay, so looking it up, you should know that cesium is a lot smaller than your I mean lithium is a lot smaller than your cesium, making your lithium a hard acid. Okay? So hard acid siya, right? So making, so you would have okay, lagay ka na lang. So hard acid to, this would be a soft acid, meaning ang base nito would be soft and ang base nito would be hard. Okay, making your hard and soft interaction in your product na. Okay, meaning this one favors the forward reaction. Okay, comparing naman dito, the astatine and phosphorus, you should know that astatine is a soft acid and phosphorus is a hard acid. Okay, and fluorine naman is a hard base and iodine is a soft base. Comparing these two, you should actually know that they would form a soft and hard interaction, favoring the forward reaction, similar to your magnesium oxide and barium sulfide, no? Because magnesium and oxide are hard acid and bases. Remember that alkaline metals are hard acid. Okay, oxygen is hard because it is small and has a hard charge +2. Okay, so that is how you use your X sub for applications. All right. So so going back to your X sub and your acid base definition, you should know that ang pinaka-useful, ang pinaka-batak, ang pinaka-powerful would be your hard, soft, acid, and bases. Okay, this is the reason why um, you study, the first three before you encounter your X sub because the definition itself goes back man din sa imo 3 definition, but your X sub now is a lot more powerful because it could actually predict the stability of your reaction and the direction of your reaction, no? Okay, so very powerful si X sub. um Okay, ang pinaka-kengkoy, si Arrhenius, sumunod si Bronsted-Lowry, sumunod si Lewis, tapos ang pinaka-powerful would be X sub. Again, X sub, on that note, is only a qualitative, determination or tool. Okay, it does not see the acidic character of a compound really, but only the interaction or the possible stability. Remember that sinasabi ko lagi, generally stable. There are some cases na hard soft interaction um, na stable man. Okay? So, not all hard soft interaction are unstable. Okay? Okay, such as your SO3 minus. No? This one is a stable compound. This one is a hard acid. This one is a soft base. Okay? Even though hard soft ang interaction, this one is still stable. Okay, so H sub is only for qualitative determination of qualitative analysis. Okay?